Ever found yourself pondering where all the stuff that goes into a black hole ends up? Think of black holes as the ultimate space mystery, a riddle wrapped in an enigma, shrouded by cosmic shadows. They're the ultimate dare to the curious mind, daring us to unravel their secrets. Black holes are often depicted as cosmic vacuums, relentlessly sucking up everything in their vicinity. You might envision them as celestial hoovers, gobbling up stars, gas, dust, and the occasional unwary spacecraft. But this image, while dramatic, doesn't quite hit the mark. In reality, black holes are regions of space where gravity has gone rogue. The gravitational pull is so strong that absolutely nothing can escape. This includes particles, electromagnetic radiation, and yes, even light itself. They're like the universe's version of a one-way street where all roads lead in, but none lead out. Now you may wonder, how can something be so powerful? Well, a black hole is formed when a massive star collapses under its own gravity. This collapse results in a tiny region of space with a gravitational pull so intense that it warps and twists the fabric of space-time itself. It's a bit like a cosmic whirlpool sucking everything into its inescapable grasp. But it's not all doom and gloom. Black holes offer a tantalizing glimpse into the unknown. They're at the forefront of our quest to understand the universe and its rules. They challenge our comprehension of what's possible, pushing the boundaries of our knowledge and understanding. They're a testament to the unfathomable complexity and grandeur of the cosmos. Even though black holes are often feared, they're also deeply fascinating. They're like the universe's wild card, a joker in the cosmic deck. They're a stark reminder that the universe is filled with uncertainties and mysteries waiting to be solved. So, as we delve deeper into the world of black holes, remember this: black holes, though terrifying, are fascinating celestial bodies that challenge our understanding of the universe. Imagine standing on the edge of a precipice, one step away from falling into the unknown. That's what the event horizon of a black hole is like. The event horizon, in essence, represents the boundary of a black hole, a point of no return. It's like the ultimate cosmic boundary line, an invisible sphere around a black hole, where the gravitational pull becomes so strong, escape becomes impossible. Anything that dares to cross this boundary, be it light or matter, will inevitably fall into the black hole, never to return. This is why black holes appear black as not even light. The fastest thing in our universe can break free from this gravitational prison. The event horizon is a region where our understanding of physics is challenged and where reality as we know it warps and twists. The event horizon is the final frontier, beyond which lies the enigmatic heart of a black hole. What occurs when matter crosses the event horizon and plunges into a black hole? Well, let's try to decipher this cosmic enigma together. The first thing you might imagine is utter destruction, and you wouldn't be wrong. But the manner of this obliteration is far more fascinating than you might think. Picture yourself falling into a black hole. As you move closer, the pull of gravity becomes stronger at your feet than at your head. This difference creates a stretching effect, and you'd start to elongate, just like spaghetti. This process, aptly named spaghettification, is one of the bizarre phenomena that could occur inside a black hole. Now you might be thinking, all right, I've been turned into a cosmic noodle. What's next? Well, according to some theories, you'd be compressed into an almost infinitely small point. This is due to the colossal gravitational pull inside a black hole, which could squish even the most robust of objects into a tiny speck. But here's where things get really weird. Some physicists propose that black holes might be gateways to other universes or dimensions. It's a radical idea, but not entirely baseless. You see, the laws of physics as we know them break down inside a black hole. So it's entirely possible that once you cross the event horizon, you're entering a realm where different rules apply. And finally, there's the idea of a firewall, a theoretical wall of high-energy particles that would incinerate anything that dares to venture into a black hole. This concept was proposed as a possible solution to the so-called black hole information paradox, a puzzling question about what happens to the information about the physical state of things that fall into a black hole. Though these theories are intriguing, remember, they are just that, theories. The inside of a black hole remains a mystery. And perhaps that's just as well. After all, some secrets of the universe might be best left unexplored. At the heart of the black hole lies an enigma, the singularity. A point where mass is thought to be infinitely dense, confined within an infinitesimally small space. It's as if the universe has crumpled a piece of matter into an unimaginably tiny dot. This is the singularity, an area where the gravitational pull is so strong it warps and contorts space and time into a single point. It's a bit like crumpling a sheet of paper into a ball. The surface is still there, but it's been compressed into a form that's unrecognizable. But here's the thing. When we talk about infinities in physics, it usually means that our understanding of the universe has hit a roadblock. In the case of the singularity, the laws of physics as we know them just don't apply. It's a zone where the familiar physical constants no longer hold true and where our mathematical models break down. It's like trying to divide by 0 on your calculator. The result is undefined. In the same way, our current theories, including Einstein's theory of general relativity, fail to define what happens at the singularity. So we're left with a paradox. A black hole is both incredibly simple, described by just 3 properties: mass, charge, and spin, and yet at its heart it harbors the most complex and least understood regions in the universe. The singularity is where our understanding breaks down, and new physics might be needed to fully understand it. So, where does all the stuff that falls into a black hole actually go? That's the million-dollar question, isn't it? There are a few theories to tackle this cosmic conundrum. One theory suggests that black holes might be connected to white holes. If you're wondering what a white hole is, it's basically the opposite of a black hole. While black holes pull everything in, white holes are said to eject matter out. So in theory, anything that falls into a black hole might come out through a white hole somewhere else in the universe. Sounds like a cosmic recycling plant, doesn't it? But hold your horses, we're not done yet. There's another theory that suggests matter doesn't really disappear into the black hole. Instead, it gets plastered across the black hole's event horizon, kind of like a cosmic billboard, storing all the information about the stuff that fell in. It's a bit like you being turned into a detailed painting on the wall of a black hole. There's a third proposition, known as the holographic principle, suggesting everything inside a black hole is actually encoded on its surface, again at the event horizon. This theory treats the event horizon like a boundary, preserving the information about everything that's fallen in. But before you start betting on any of these theories, remember, they're just that, theories. We don't have any concrete evidence to back them up yet. And that's what makes black holes so fascinating and frustrating at the same time. They're these cosmic mysteries that we're still trying to unravel. Until we can get closer to a black hole or develop new physics, the question of where stuff goes remains unanswered. So for now, we're left with theories, speculations, and a universe that just keeps getting more and more intriguing. But isn't that the beauty of exploring the cosmos? The more we know, the more we realize how much there is left to discover. Black holes continue to be one of the universe's greatest mysteries. An apt statement to begin this concluding scene as we've journeyed through the enigmatic depths of black holes, a journey that's left us with more questions than answers. We've traversed the event horizon, the point of no return, where light itself surrenders to the insatiable pull of the black hole. We've peered into the unfathomable innards of these celestial beasts, where the laws of physics as we know them crumble and give way to the unknown. We've grappled with the concept of singularity, a point of infinite density at the heart of a black hole, where space-time curves infinitely, confounding our understanding of reality. And we've pondered the ultimate question: where does all the stuff that gets sucked into a black hole actually go? Through it all, one thing is abundantly clear. Black holes are not just fascinating, they are a testament to the endless wonders and complexities of our universe. They challenge our understanding, push the boundaries of our knowledge, and invite us to delve deeper, to question more, to never stop learning and exploring. So, let's keep seeking, let's keep questioning, let's continue to be awed by the mysteries of the cosmos. Because as we continue to explore the cosmos, who knows what new secrets black holes will reveal? Have you ever wondered what possibly could be inside a black hole? Let's take a moment to dive into the cosmic enigma that has puzzled astronomers and physicists alike for years. Black holes, first theorized by Albert Einstein in his theory of general relativity, are regions of space where gravity is so strong that nothing, not even light, can escape its pull. At the heart of a black hole lies an event horizon, a boundary beyond which we cannot see or gather information. It's like a cosmic point of no return, where the known laws of physics cease to apply. The very existence of black holes challenges our understanding of the universe, making them one of its biggest mysteries. These celestial phenomena are not just voids in space, but are entities with enormous gravitational pull, capable of swallowing stars and bending light. So, what could be inside these fascinating yet terrifying cosmic behemoths? Well, there are several theories, each more mind-boggling than the last. One of the most popular theories is that at the heart of every black hole lies a singularity. Now, let's break down what this singularity is all about. The singularity theory proposes that the matter inside a black hole compresses into a point that is infinitely small. Yes, you heard it right, infinitely small. Hard to imagine, isn't it? But that's the beauty of astrophysics. It often takes us beyond the realms of our everyday comprehension. So how does this happen? Well, when a massive star collapses under its own gravity, it forms a black hole. The gravity of this black hole is so intense that it starts pulling in everything around it, even light. And when matter gets pulled in, it doesn't just float around. Oh no, it gets squeezed into this tiny, dense point called a singularity. Picture a full-size car getting compacted into a cube the size of a marble. Now imagine that happening to an entire star or even a whole galaxy. Singularity theory aligns quite well with Einstein's theory of general relativity. Einstein's equations predict that any matter inside a black hole gets infinitely compressed at a single point in the center. This point is what we refer to as a singularity, but here's where it gets even more mind-boggling. According to the same equations, the singularity exists in all times at once. It's a timeless, spaceless point where the usual laws of physics no longer apply. And it's not just about compression. The singularity also has an immense gravitational pull, which could potentially bend time and space around it. This leads some to speculate that singularities might be the gateways to other universes or dimensions. But let's not get ahead of ourselves. These are just theories after all. They're our best attempts to understand the incomprehensible, to make sense of the cosmic enigmas that black holes present. So, in theory, a black hole could be a cosmic vacuum cleaner, sucking in everything and compressing it into an unimaginably small space. Another fascinating theory proposes that black holes could be gateways to other universes or distant parts of our own universe. Now, that's a concept that could bend your mind a little, isn't it? But let's delve into this idea known as the wormhole theory. Imagine space as a two-dimensional sheet. If you wanted to get from one side to the other, you could go the long way round. Or if you could somehow bend that sheet, creating a tunnel through it, you could take a shortcut. This tunnel is what we call a wormhole. But here's the kicker. Wormholes aren't just science fiction. They're a genuine prediction of Einstein's theory of general relativity. In essence, they are a solution to his equations that describe the fabric of the universe. However, it's important to note that while the math allows for their existence, we've yet to find any concrete evidence of wormholes in our universe. One end of a wormhole is theorized to be connected to a black hole, while the other end could be connected to a white hole, essentially the reverse of a black hole, spewing out matter rather than sucking it in. This could mean that if you were to somehow survive the journey through a black hole, you might be ejected out in a distant part of our universe or even into a different universe altogether. Now, to make things even more interesting, if wormholes do exist, they could potentially allow for faster-than-light travel. This is because the path through the wormhole could be significantly shorter than the path through normal space. It's a bit like folding a piece of paper and pushing a pencil through it. The pencil takes a shortcut, bypassing the space in between. However, before you get too excited, it's worth noting that wormholes, if they exist, would likely be extremely unstable and might collapse instantly. But who knows? With more research and a better understanding of the universe's mysteries, we might one day find a way to use these cosmic shortcuts. Imagine stepping into a black hole and ending up in a distant galaxy or even an entirely different universe. Now that's a journey worth contemplating, isn't it? Then there's the firewall paradox, a theory that challenges the fundamental principles of quantum mechanics. This theory introduces a new twist to the tale of black holes, and it's as fiery as it's intriguing. Let's delve into the enigma that is the firewall paradox. The theory suggests that a firewall of energy could exist at the event horizon of a black hole. The event horizon is the point of no return, the boundary beyond which nothing, not even light, can escape the gravitational pull of the black hole. Now, imagine this boundary being a wall of high-energy particles, a literal firewall, incinerating anything that dares to get too close. This idea was first proposed by a group of physicists in 2012 and has since sparked much debate in the scientific community. The firewall paradox challenges the principle of no drama, a key component of Einstein's theory of general relativity, which states that crossing the event horizon of a black hole would be uneventful from the perspective of the object falling in. But if there's a firewall, that would be quite an event. The implications of the firewall theory are profound. If true, it would mean that the event horizon is not just a boundary in space-time, but a physical barrier. This would fundamentally change our understanding of black holes and, by extension, of the universe itself. But where does the paradox come in? Well, the existence of a firewall contradicts quantum mechanics, which suggests that information can't be lost in a black hole. If there's a firewall, then the information about the objects that fall into the black hole would be destroyed, leading to a loss of information. This is a direct contradiction to the principles of quantum mechanics, creating a paradox that scientists are still trying to resolve. In this light, black holes aren't just cosmic objects of curiosity. They are the ultimate testing grounds for our understanding of the physical universe. So, instead of a gateway or a singularity, a black hole could be the universe's most deadly firestorm. Lastly, let's delve into one of the most bizarre theories: black holes as holograms. Yes, that's right. We're not talking about the kind of holograms you might find in your favorite sci-fi movie, but a scientific concept that challenges our understanding of reality. This is the hologram theory. It suggests that the three-dimensional world inside a black hole is not actually three-dimensional at all. Instead, it's encoded on the black hole's two-dimensional event horizon, just like a hologram. Mind-boggling, isn't it?